Question number 91. Which of the following oxides show conducting or insulating properties depending on the temperature? So if I talk about these oxides, these are VO, VO2, TiO3. All of these are showing the conducting or insulating properties that depends on temperature. That's why option 4 becomes my correct answer for this question. After that, now here's question number 92. If for a strong electrolyte following data is given, we have the molar conductivity here in centimeter square, ohm inverse, mole inverse, concentration in the terms of molarity is given, then limiting molar conductivity in the same unit, centimeter square, ohm inverse, mole inverse is. Basically for the strong electrolyte we know that the relation between molar conductivity and the limiting molar conductivity is, I'm just writing here, that is A constant root C. This is the relation. Now, on the basis of this, we can imagine the first case when the molar conductivity is 500, limiting molar conductivity we don't know, minus A is the constant, that's why I'm taking it as A, and concentration is given, that is 4. So this could be simplified by writing 500 is equal to limiting molar conductivity minus 2A. Similarly for the second case, where molar conductivity is 100, limiting molar conductivity we don't know, A root concentration, that's 16, and the simple form for this is 100 is equal to limiting molar conductivity minus 4A, it could be written as. Now let's assume this is equation 1 and this is equation 2. I'm just assuming. Now what you did, you just subtract equation 2 from 1. So I'm just writing here subtracting equation 2 from 1. So I'll just directly do here. What will happen? This would becomes 400 is equal to, this would be cut in this way, and here would be 2A. So the value of A is 200 here. Now you know the value of A, this one. On the basis of that, we can find out limiting molar conductivity by placing the values. Molar conductivity is 500 in the first case once again. That is equal to limiting molar conductivity, we don't know, minus the value of A is 200. Root C is root 4 basically. So once again here this is 2 into 2, 400. So it would becomes 500 plus 400, that's equal to limiting molar conductivity. And this value is 900 centimeter square, ohm inverse, mole inverse. This is the final answer. Where this is given, it's given in option 4. So just choose option 4 as your correct answer. After that, question number 93. For an elementary reaction are those reactions for which stoichiometric coefficients are used in the calculation of order of the reaction. So the reaction that I'm just going to write again, X reacting with Y giving you Z as per this reaction. The initial pressure of X and Y are 60 and 80 mm of Hg. I'm just directly writing here 60 for X and 80 for Y. And it was when T was 0 minutes. Now, Z is 0 initially, so pressure is also 0. After 20 minutes, it means when time becomes 20 minutes. What will happen now? In this case, let's assume the pressure of Z is P. So it can be written as 2P. Now, on the basis of this, it becomes 80 minus 2P. And what about the pressure of X? That would be 60 minus P. So this would be the pressure. Now, we know that the value of P is given in the question. Let's check. Now, after this, it is said after 20 minutes, pressure of Z is 40 mm of Hg. Ratio of the rate of reaction after 20 minutes to the initial rate is, it means we need to just find out this ratio. And one more thing that we know here is the after 20 minutes pressure of Z, that is Pz, it is equal to 40 mmHg. This is the fact that's given here. On the basis of that, we can say that the pressure 2P is equal to 40, as per the question we can say, mmHg. And now let me just place it in a bracket. On the basis of that, let's check what will happen after 20 minutes. It is 60 minus P. If 2P is 40, then P is 20 definitely, and the 60 minus P becomes 40. So the pressure of X after 20 minutes becomes 40. Similarly, the pressure of Y after 40 minutes would become 80 minus 40, that is also 40. And what about 2P? That we already know it is 40. Now, you need to just find out the ratio of the rate of reaction after 20 minutes to the initial rate. So let's assume that rate of the reaction initially was R1 and that K1 into pressure of X into pressure of Y. One more thing, I've already told you that this is an elementary reaction, and for this reaction stoichiometric coefficients are used in the calculation of order of the reaction. So in this case, Py raised to the power 2 I should write in this way. So this could be written as, in the initial form it can be written as K, and what is Px initially? That was 60, and what is Py initially? It is 80 square. What about R2? In the similar way, it is K, the pressure of X, pressure of Y raised to the power 2, and it can be written as K into. What about pressure of X after 20 minutes? We already find it out. This is 40 into 40 square. So what would be the ratio of rate of reaction after 20 minutes? That is R1. It's equal to K into 60 into 80 into 80. And should be divided by K into 40 into 40 into 40. This would be the equation. Now it can be cut. These are 2 times further. This is could be cut in this way. 3 by 2. So it can be written as, this 2 can be cut. 6 by 1. K is also cut in this way. This would be the ratio. 6 by 1, R2 by R1. So R1 by R2 1:6. So the ratio of the rate of reaction after 20 minutes to the initial rate of reaction is 1:6. So on the basis of that, the answer becomes option 2. After this, there's another question. Question number 94. If rate constant and the rate of reaction both have same unit, then the order of reaction is. We should know that in case of zero order reaction, the unit of K is mole per liter inverse second inverse. This is the unit, and similarly the unit for rate is also mole per liter per second. Both the units are same, and on that basis we can opt option 1 as the correct option. After this, there's another question. Question number 95. If a solute AB2 40% dissociate behaving as ternary electrolyte, it means 3 ions it is forming, and 60% dimerizes, it means 2 molecules dimerize to form a single molecule, then its Van 't Hoff factor I is. In this case, I can give you a simple formula with the help of which you can find out. I value is equals to 1 minus alpha.
Alpha is the number of species obtained after association or dissociation of 1 mole of substance,
Plus N1 alpha 1
degree of dissociation
plus alpha 2 by N2. In this case, alpha 1 I am taking for the process of dissociation, and alpha 2 I am taking
degree of association
means for the dimerization process. So in this case, I would becomes 1 minus 1 when 100% dissociation is assumed, plus N1. It means ternary electrolyte it is. It means 3 ions are formed by the one single species. So further multiply alpha 1, that is 40%. 40% means 40 by 100, 0.4, plus alpha 2, that would be 60%, 0.6 we can take, and combination of two molecules to give rise a single molecule is there, it means N2 is 2. Let's solve this. It becomes 1 minus 1, 0 it becomes. Further, it is 1.2 plus 0.3. That is equal to 1.5. So I value is 1.5 in this case. That's given in option 3. Just choose that option as your correct option. After that,